Hi everyone. Today let's discuss about Unit 8 Organic Chemistry, some basic principles and techniques. Let's start with a brief introduction. By this time we understand that carbon has a unique property called as catenation. Catenation means carbon can form four bonds, especially four covalent bonds with other carbons. So this special property helps the carbon to make new structures, new compounds with almost all the elements like hydrogen, oxygen, nitrogen, sulfur, phosphorus and halogens. The compounds that we derive from the carbon is called as organic chemistry. Whatever the chemistry we discuss related to the carbon is called as organic chemistry. We can simply say that this is equal to carbon chemistry. Even though in our periodic table we have more than hundreds of elements, carbon plays a very important role in real time. It's mainly because we find the carbon atoms in almost all the walks of life, like starting from our DNA, then the polymers that we see in our life, like our hair, our dresses, and even the petrochemicals, petroleum and diesel, our food items. Many of them contains primarily carbon, and we get energy from carbohydrates, where carbon is the backbone, right? So this is how, or this is why carbon compounds are very important, and this is why we would like to study more about the organic compounds. In fact, most of the medicines have mainly carbon backbones. Okay, carbon backbones in the sense they are all made up of carbon compounds, where we will have additional elements like hydrogen, oxygen, nitrogen, sulfur, phosphate, or sometimes halogens, or some other elements also. Okay, in fact, around 1780s, there was a chemist who started to understand that there is a possibility for two different chemicals. One is inorganic and the other one is organic. His name was Berzelius. Berzelius. Okay. This Swedish guy, thought that for making organic compound, you need divine intervention. It means that only God can make such organic compounds and the humans cannot make. But that was very shortly broken by Mr. F. Waller. Okay, in 1828, F. Waller synthesized urea. This is the first organic compound to be synthesized in the modern scientific era. And then several other people started to synthesize many other compounds, organic compounds. This is the start of the organic chemistry. Next, let's discuss about the tetravalence of carbon, shapes of organic compounds. Okay, so in the volume 1 chapter, we understand that in the atomic structure chapter, we understand that there are hybridization, right? So hybridization is the best way to understand the shape of the organic molecules. Okay, so let's see some of the examples. Let's say methane. Methane has a hybridization of sp3, and ethane C2H4. Okay, this one is called as ethene. This one is methane. This one has ethene. This one has a hybridization of sp2, whereas C2H2 ethine, it has hybridization of sp, right? So here one thing we should remember, uh, methane has sp3 hybridization because it can, the carbon is connected with four hydrogen atoms. Okay, so it forms a structure of a tetrahedral structure like this. Hence it has the hybridization of sp3, whereas ethene has a different structure. We can write the ethene molecule like this, C2H4, which you can write like CH2 double bond CH2. Okay, here you have two carbon atoms. Both the atoms have same hybridization, and let's try to write the full structure. In fact, in the later slides we will try to understand how to write these kind of structures. For the moment, you simply follow my lead so that you can understand what we are trying to figure out. Okay, so like this we can expand the structure. Okay, this is called as a full structure of a molecule. Here you can see that the carbon is attached to two atoms. Okay, and hence it is called as sp2 hybridization. This carbon has sp2 hybridization, and this carbon also has sp2 hybridization. Okay, and what about the third molecule, ethene, ethine? This one we can write like this, CH triple bond CH. So the full structure of this one is CH H. Okay, here you can see that the carbon atom is attached to only one atom. Okay, and hence this hybridization is called as sp hybridization. Okay, I think now you can understand the difference. Here one thing we can compare between the atoms, I mean hybridization, or the elements, organic compounds. In this case, the percentage of S character and P character we can determine for all the three types of hybridization. Okay, when we talk about the uh, hybridization, it is important to note that hybridization influences the bond length and bond enthalpy. So when we say this compound has sp hybridization, this means that it has 50 percentage of S character and 50 percentage of P character for ethane. Okay, this means that when we compare with other two hybridization, or when we compare the other two molecules, this ethane has more electronegativity. Okay, because here the percentage of S character is lesser. It's like 1 is to 3 in this case, and here it is 1 is to 2, but in this case it is 1 is to 1. So when we talk about when they are equal, there is a possibility for more alternativity. And the triple bond, that is why we say the triple bonded compounds like this alkynes have or has more electronegativity. Okay, this point is important, so you can note it down, right? So let's move to the next section. From the previous slide you understood that there are two types of compounds, right? Okay, let's try it again. this is called as methane, and this compound, okay, can be written shortly as C2H6. Okay, this is ethane. So this kind of bonds are called as single bonds or sigma bonds. And when we talked about ethene, there were two types of bonds, right? One is sigma bond, the other one is pi bond. And when we talked about the ethane, we understood that there are two pi bonds and one sigma bond, right? So first we have to understand that sigma bond and pi bond are not equal. Even though there are sharing of electrons, their strengths are totally different, because pi bonds are formed by p orbitals that are overlapping sideways. Okay, so when we compare with the sigma bonds, they are formed by head on head interaction. Okay, you can simply go through the first volume notes, so that you can understand what is in by hybridization or overlapping of the orbitals. Okay, so head on head interaction of the orbitals. Okay, so you can easily understand that relatively these pi bonds are weaker than the sigma bond. Okay, this is first point to note. Let's say you are given ethene. Okay, when I try to attack this molecule with any reagent, let's say X, which bond will be broken? Let's imagine this is sigma bond and this is pi bond. When there is a molecule, say X, where it will go on an attack, in fact it will readily attack the pi bond, because pi bond orbitals are always lie above the plane. Okay, other bonds and atoms will lie on the plane. Okay, so these electrons, pi bond electrons, are easily attacked by any other reagent. Okay, so because of this reason, whenever there is a reaction, the pi bonds are attacked and there will be formation of the compounds. Okay, sigma bonds will stay stronger and they will continue with the same backbone structure. Whenever I say backbone, it means that the sigma bonds. Okay, and whenever we say there are pi bonds, they are additional ones which can be uh, attacked or substituted by some other atoms or molecules. Okay, so this is the basic thing. Sigma bonds are stronger, pi bonds are relatively weaker, and whenever there is a reaction, pi bonds are the first ones where reaction will occur. Okay, so there are some problems in given in your book. You can follow our other videos to